Given question is resistance of 0.2 molar solution of an electrolyte is 50 ohm. The specific conductance of the solution of 0.5 molar solution of same electrolyte is 1.4, and the resistance of the same solution is the same electrolyte is 280 ohm. The molar conductivity of 0.1 molar solution of the electrolyte is 5 मीटर स्क्वायर पर मोल. ये है. तो जो क्वेश्चन में गिवन बच्चों उसी का ध्यान देते हैं. यहाँ पे क्या दिया हुआ है, रेजिस्टेंस ऑफ, ठीक, इलेक्ट्रोलाइट का रेजिस्टेंस ऑफ इलेक्ट्रोलाइट कितना दे रखा है, 50 ओम दे रखा है. स्पेसिफिक कंडक्टेंस कितना दे रखा है बच्चों, स्पेसिफिक कंडक्टेंस ऑफ सॉल्यूशन 1 सीमेंस पर मीटर, ये दिया हुआ. अब जैसे दिया हुआ सॉल्व करते हैं बच्चों. R इज इक्वल टू क्या होता है, 1/k इंटू 1/a, ये रिलेशन होता है. हमें यहाँ से रेजिस्टेंस दिया हुआ है 50 इज इक्वल टू 1/1.4 इंटू एरिया की वैल्यू हमें पता करनी है. तो 1/a की वैल्यू यहाँ से कितनी आ जाएगी, 70 पर मीटर. ठीक, अगेन अब देखिए आगे. अब आगे की बात करें तो अगेन 280 इज इक्वल टू 1/k इंटू 17, ये ले सकते हैं. यहाँ से k की वैल्यू कितनी आ जाएगी, 1/4 सीमेंस पर मीटर. ठीक, अब मोलर कंडक्टिविटी के टर्म्स में बात करें तो मोलर कंडक्टिविटी इज इक्वल टू क्या होता है बच्चों, कप्पा इंटू 1000 अपॉन कंसंट्रेशन इंटू 10⁻⁻² का होल क्यूब. और यहाँ से वैल्यूज़ को रखें तो यहाँ से वैल्यूज़ को रखेंगे बच्चों तो क्या हो जाएगा, 1/4 इंटू 0.5, ठीक है, इंटू 10⁻⁻6. यहाँ से मोलर कंडक्टिविटी की वैल्यू कितनी आ जाएगी बच्चों, मोलर कंडक्टिविटी की वैल्यू आ जाएगी 5 इंटू 10⁻⁻4 सीमेंस मीटर स्क्वायर पर मोल. ये है करेक्ट आंसर. तो कौन सा ऑप्शन बच्चों करेक्ट होगा, ऑप्शन फर्स्ट इज करेक्ट आंसर.
Hello everyone, let's start the given question. The question says that an aqueous solution of X is added slowly to an aqueous solution of Y as in column number 1. The variation in conductivity of these reaction is given in column number 2. Match column 1 with column 2 and select the correct answer using the code given below in the options. So we have been given list A where we have been given examples of 2 solutions, and list B we have been given their variation with the conductivity. So let's start with the first option. In list A we have been given C2H5 whole thrice N plus CH2COOH. So this should be actually CH3COH, that is acetic acid it should be, and that is triethylamine. So in option number P we have a weak base, that is triethylamine, and acetic acid is a weak acid. So we have a combination of a weak acid and a weak base. So this means that the conductivity will not change much, right? So it means that there will be not much change in the conductivity, but it will increase. Why it will increase? Because initially the conductivity is due to the presence of acetic acid, right? And when we'll add a weak base to it, so its conductivity, so H plus ions will get neutralized by the weak base here present, but it will not change much. So option P matches which option? It matches fourth option from column number 2. Now moving on to the second, we have Q, and in option number Q from column number list A we have Ki and silver nitrate solution. We have Ki, that is potassium iodide, and we have silver nitrate which is AgNO3. Now Ki is ionic in nature, and so silver nitrate is also. Both are examples of strong electrolyte. So we can say that to Ki solution I am adding another solution of AgNO3 which is a strong electrolyte. So when I am adding a strong electrolyte to already a strong electrolyte, it means that its conductivity will not change much, but it will increase, right? Because why it will increase? Due to the presence of the ions, because Ki will also get dissociate easily, and so will silver. Nitrate will also get dissociated easily. So it matches which option? So firstly, option number Q matches option number 4, whereas option number P actually matches which option? It matches option number 3, because both have similar here. Saying first, option 3 says conductivity increases. So here it matches which option? That means Q option matches option number 4 and P matches option number 3, because it says that conductivity increases and then does not change. Option 4 says conductivity does not change and then increases. Why? Because initially volume is being added to it, but then when the dissociation takes place, so conductivity increases, because conductivity depends upon the number of ions. So the greater the number of ions will be there, the more the conductivity will be. Option R, we have acetic acid and KOH. So acetic acid, which is CH3COH, and we have base, which is KOH. Acetic acid is a weak acid, KOH is a strong base. So initially what will happen here, since we are adding a weak acid to a strong base, the conductivity will decrease. Why conductivity initially was high? Because of the presence of OH negative ion, that is hydroxyl ions in the solution. So the conductivity was initially high, but as we added a weak acid, so it started neutralizing the OH negative ion, so the conductivity decreases, and then the conductivity becomes constant, then it does not change, right? Because why it does not change? Because acetic acid is a weak acid, does not dissociate completely, only dissociates to a small extent. Option S. So option R will match which option? It matches option number 2. Then coming to the last one that we have here, option number S, it says that NaOH and HI, this is the combination given to us. Now this is NaOH is a strong base and HI is a strong acid and strong base. So initially conductivity will decrease because of the neutralization, and then it will increase afterward because of the presence of the increase of H plus ions in the solution due to the dissociation of HI in the solution. So option S matches which one? It matches first option. So out of the following option, which option is correct here? P matches third one, so and S matches first one. So option number 1 is your answer to the question. Thank you.
Hello everyone, this is our question. Let me explain it to you. Consider the following reaction. Iron reacts with oxygen plus 4H plus ions. It's a net reaction that is given to us. 2 Fe2 plus and 2 electrons, E0 to water, and E0 for this is given to us. Also, we are provided with concentration of ferrous ions and pressure of oxygen, and pH is also given to us. Now, first of all, from the pH value, we would be calculating the H plus ion concentration. pH is equal to minus log of concentration of H plus ions, right? So pH value is given to as 3 is equal to minus log of concentration of H plus ions. Taking the antilog, here H plus ions can directly be calculated as 10 raised to power minus molar concentration, right? Now the next thing, we would be writing the EMF expression directly. That would be equal to E0 of the cell minus 0.059 divided by N value is the electrons involved in the reaction, into log of concentration of product ions. So we can see Fe2 plus ions are there. So concentration of Fe2 plus raised to the power stoichiometric coefficient 2. Water is liquid, we don't need to take for this, unity will be considered. And then concentration of H plus ions, that is in the reactant in the denominator, raised to the power stoichiometric coefficient multiplied by pressure of the oxygen gas. In solid states we will not consider. So pressure of oxygen is 0.1 atm. 0.1. So now if we see the N factor, how many electrons are involved? So if we see, there is a net positive 4 positive charge. Here also 4 positive charge. So it means 4 electrons are also involved in the reaction. Okay. So reaction will become E0 cell given 1.67 minus 0.059 divided by 4 into log of concentration of Fe2 plus given. It will become 10 to the minus 6 into 0.1 into H plus ion concentration, 10 raised to power minus 3 raised to the power 4. We have already calculated H plus. Now on solving this expression, EMF we be getting as plus 1.57 volt. Going above, option number D is the correct answer. Thank you.